Hey there, this is 6th grade, Unit 1, Lesson 15. And in this lesson, we continue exploring polyhedra and all of that vocabulary, faces, edges, vertices, all that junk. So we're going to continue exploring polyhedra solids and their connection to the nets and surface area. And we're starting to dip our toes into volume as well. So let's get started. So we're going to begin this lesson today with a notice and wonder. Notice and wonder, parents and teachers, in case you're not familiar, is a protocol. It's a routine where we give students, in this case, this rectangular prism, and we ask them, what do you notice? And what do you wonder? And we engage in a nice, wonderful conversation that might grow into something like really longer and meaningful. It kind of depends on the students. But really, your goal is to keep this like nice and brief, like a 5-minute conversation. Teachers, please don't let this slip into a mini lesson. We're basically thinking, what do we want kids to notice? Well, we notice that one edge length is 4 inches. We notice that another edge length is 2.5. What's beautiful about this, parents and teachers, is that we are not given the height, which means students are literally prevented from finding volume or surface area because we really want to keep it simple to what do you notice, what do you wonder? All right, so that's a nice little 5-minute conversation. All right, so now the big bulk of our lesson today, about 30 minutes or so. The teacher, you're going to give your students a polyhedron, a drawing of a polyhedron, and then students will have to grapple, working in groups, they're going to grapple with what does that net for the polyhedron look like? And then once they've drawn the net, their job is to calculate the surface area. So this is the real bulk. This is really exploratory. So teachers, avoid stealing the joy of discovery. Just let your students grapple. Your job today in this lesson is to be the cheerleader and keep that growth mindset going on in your culture, in the class, and with the kids. So they're going to answer 4 questions. What polyhedra do you have? And then draw your net, label everything, and then the 4th part is find the surface area. So let's start with, let's just imagine B. Now, I'm not going to do all the work here because that literally will steal the joy of discovery. But the idea is take a look at B here, and our student's job is first label it. Oh, okay, that's a triangular prism. There's not much going on there. So that's a triangular prism. All right. Yay. And then the next thing they're supposed to do, what is it? Draw the net. Now, you might want to give students graph paper. That might help. It might make, it says on graph paper. There you go. Because that might make the student's life a little bit easier to really think about this triangular prism and its component parts, like what makes that triangular prism. And we want students to be saying things like, I see a rectangle right here that is 10 by 15. And then they might say, but then if that's 10 by 15, I see another rectangle way back here. And what are the dimensions of that rectangle? And let students grapple with it. Well, we see that rectangle looks like it's 8 units high. What is the width of that rectangle? And they should see that, it's also 15. That this 15 and this 15 go together, so to speak. And heck, as long as I just highlighted those 2 rectangles, we might need to, we want students to see that there's this base rectangle, this rectangle that kind of is on the bottom. What are the dimensions of that rectangle? And then lastly, we have a couple, I want red. We have a couple of triangles right here, the top and the bottom, the bases. So I kind of incorrectly called this thing. I called it the base. Well, because it's sitting on, it's sitting on that thing. But that's not technically that's not the base. That just happened to be the bottom. The real base in this case are the two triangles right here, and right here, because that's how it's going to stand up on its end, right? So we want students to recognize that we have 1, 2, 3, 4, 5 different faces of this triangular prism. And once we've identified the dimensions of each of those things, we want to draw them on graph paper to form a net. And then once we've got that net drawn, and then we want to label each face as things, and in fact I was already doing it. Label each face as a rectangle or a triangle or whatever that face is. In this case, they're all either rectangles or triangles. And then the last step is find the surface area. So we have these 5 faces. We have a rectangle. In this case, we had a rectangle. The green rectangle was 10 by 15. We had that blue rectangle, which was 6 by 15, etc. And you find all of the different faces, find the area of those different faces, and add that up. Find the sum. That gives you your surface area. Same idea here. Now, the reason I showed this one is it doesn't clearly indicate this, but parents and teachers, you might want to, if students have the question. So we clearly see that the base right here is an 8 by 8 square, and we see that the height of this triangle right here is 11. But what we're not told anywhere is that these are probably equilateral triangles, meaning that this length and this length are the same, creating an equilateral triangle right here, which means, oops, what the heck happened there? Okay, meaning that they're probably all equilateral triangles and that all of these triangles are the same. I don't think they have to be, right? So in order for it to be a pyramid, I mean. So let's just go with the fact that all of these are equilateral triangles and they're all the same triangle, right? And each triangle has a base of 8 and a height of 11. So that'll be a fun net to make. And in both cases, parents and teachers, there's a lot of different nets that students could draw for each of these figures. There's not just one answer. All right, that's the big bulk of the assignment, of the work this day. There is a brief optional portion of this lesson if you want. The idea is we have these different nets right here with a little bit of a story saying, okay, these are cardboard boxes and they're going to hold centimeter cubes. And so in this portion, students are starting to connect surface area to volume, which is when you're packing a box with cubes, right? And over here, the idea is we're supposed to find all of the surface areas of the boxes. Pretty straightforward. Which box is going to use the least cardboard? How do you know? And that's basically find the area of all these faces and add them up, right? So find the area of all 6 faces here, add them up. Find the area of all 6 faces here, add them up. And then find the area of all 6 faces right here and add them up and figure out which one has the least surface area. But then question 2, we're going to push into volume right here because we're going to talk about, well, which box will hold the most centimeter cubes. So this is a little forward thinking as we talk about volume. Although, to be honest, students in 5th grade were already talking about volume, so this should not be terribly a stretch. We just haven't really gone into depth about volume this year yet. All right, and then there's our summary, nice little summary. We don't have a whole heck of a lot of vocabulary today. We're just using the old vocabulary that we've been doing. So now it's time for practice. So let's help with this practice stuff. So Jada drew a net for a polyhedron and calculated its surface area. What polyhedron can be assembled from this net? So when we create this, when we cut it out and fold it, what shape is going to be created? And in this case, it's going to be a triangular prism. Nice triangular prism. Now, Jada made some mistakes in her area calculation. Ooh, what are the mistakes? So what you're going to have to do is you're going to have to look at each of these faces and find the area, because Jada found the area, but clearly we have some mistakes. So here we've got a 4 by 5 rectangle. 4 times 5 is 20 square centimeters. That checks out. Here we've got, let's see, a 4 by 5 square. 4 times 5, we have a 4 by 4 square. 4 times 4 is 16, so we have 16 square units. So far, everything seems to be checking out, huh? And then here we've got a 3 by 4 rectangle, so that's 12. So that's 12 square centimeters. So far, everything is checking out. It's got to be some of these triangles. And we see that both triangles have the same answer of 12. So something's got to be up there. So let's take a look. So let's zoom in on this. So we remember that the formula for the area of a triangle is base times height divided by 2, or 1/2. 1/2 times base times height. So that's 4 times 3, which is 12, but then we have to divide by 2. So 4 times 3 is 12, divide by 2 is 6. There's our mistake. That should actually be 6 square centimeters, which means this is also 6 square centimeters because it has a base of 4 and a height of 3. And for this triangle, that 5 is not needed. So there's our mistake. Now to find the new surface area of this polyhedra, all we have to do is add up all of our faces, our 5 faces. So that's going to be 20 plus 16 plus 12 plus the 2 6s that we fixed. And that's our surface area. And don't forget, it's going to be in square centimeters. So when you get your answer, it's in square centimeters. All right. A cereal box is 8 inches by 2 inches by 12 inches. What is its surface area? All right, so I'll tell you what I'm going to do. I'm going to draw some sort of semblance of what they're talking about. And there we go. There's my cereal box. I love the fact that they're talking about cereal because I love my cereal. So this is 8 inches. This is 2 inches. And this is 12 inches. All right, that's how I decided to make it because it's kind of like a classic cereal box. So now our job is to find the surface area. So we know that the surface area is going to be made up of 2 fronts. Here's one front, a front and a back. And then we've got 2 of these sides. I don't know, let's call it a left side and a right side. And then we have a top and a bottom. So for each of these 3 faces, we know we have a partner, right? And so the red, the front and the back, so to speak, is 8 by 12, which is 96, but we have 2 of them, so that's 96 inches squared. And then the green we have is a 2 by 12, which is 24 inches squared, but we're going to have 2 of them. And then lastly, we have the blue. The blue is 2 by 8, which is 16 inches squared, but we're going to have 2 of them. So what we're going to do, let's add all of those together. 12, 13, 14, 15, 16, carry the 1, 10, 136 square inches. But that's just the 3 faces we can see. So now we have to take 136, multiply that baby by 2, and we get 272 square inches as our surface area. We could have done it as 6 separate faces. We would have gotten the same answer, but I decided to do just 3 faces and then multiply by 2 because each one has a partner. 12 cubes are stacked to make this figure. What is the surface area? Well, there's no real formula for this, is there? So in this case, parents and teachers, we're going to want our students to just count. And this is a nice, beautiful review of, what the heck is surface area? Well, surface area is when we're counting all these little square units that surround the prism, or this figure, let's call it. And don't forget, we also have to count the face, the little square units on the bottom that we can't see, and on the back that we can't see, and on this back that we can't see. Although there is some suggestion that this front face is going to be the same as this back face, so that we could do some assumptions here. We're going to assume that there's no hidden cubes down below underneath. So just what you see is what you get. Count and assume that there's nothing secret in the back, and that you can assume and predict what's in the back, and just count your faces. I am not going to do this one because I really want to let students work on this, but count your little faces. And so far, we can clearly see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we know the surface area has to be larger than 18, and that's a good enough hint for right now. So how would the surface area change if these top 2 cubes were removed? Ew. So if we were to change the figure by cutting those 2 off, how would it change? Would the surface area get smaller? I don't know. The volume definitely got smaller because we eliminated a couple of cubes, but what's going to happen to the surface area? I don't know. Just draw the figure and repeat the process. So here are 2 polyhedra and their nets. So here's our polyhedra, here's our nets, and we're supposed to label all the edges in the net with the correct lengths. All right. Ooh, my goodness. So A goes to A. All right. So let's take a look. So our job is, let's do it in red. All right. So I see that here's a 5 by 4. So where do I see a rectangle that looks like it might be like a top and a bottom and a 5 by 4? Here it is right here. Here's my 5. There's my 4, which means this is a 5. And this is a 4. Well, there we are. All right. And then, I see this length of 10. So where in this net are we going to have a length of 10? Well, we see this length of 10. It's right here. It's right here. It's right here. It's right here. And it's right here. And now we have to label these remaining edges over here. So let's do that. But we know 5 and 4 are our numbers. So we could see that between this length and this length, this one seems to be the 5 and that one seems to be the 4, which means that one's the 5 and this one's the 4. And since this one is the 4, that means this one is the 4. Same thing over here. Ooh, what's this one right here? That one looks like it's going to be the 4. So we got lots of 4s, not a lot of 5s. Oh, here's a 5, and here's a 5. So there, we labeled everything. We labeled all the edges in this net with the correct lengths. All right, now I'm going to let you do the same process with this triangular pyramid. Take a look at all your edges, and how do you connect those edges to the net right here, and just have fun and explore with that. All right, that's the original, but I copied and pasted to make it easier. And then 5A, what three-dimensional figure can be assembled from this net? So this is a little bit of review. So when we cut this out and fold along the lines, what shape are we going to get? Well, we're going to get another triangular prism. And I said triangular prism. Nope, 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 nope. We're going to get a pyramid. What kind of pyramid? It's going to be a pyramid with a square base. And with a square base. Now, there's some fancy words. You could call this a square pyramid, but definitely it's a pyramid, and I'm going to leave it up to the parents and the teachers how you kind of indicate whether that's got a base of a triangle, base of an octagon, but I tend to call it either a pyramid with a square base, or we could call it a square pyramid. And then our job is to find the surface area of this figure. All right, so as we zoom in, and our job is to find the area of all the faces and add them together, right? So this triangle right here has a base of 4 and a height of 1, 2, 3, 4, 5, a height of 5. So 4 times 5 is 20, but divide by 2 gives you 10. So that triangle right here has an area of 10 square units, which means that is 10, that is 10, that is 10, because they were all the same. And then we could see that this is 4 by 5, so it's got an area of 16. So what are we going to do to find the surface area? We're going to add them all together. And don't forget, your answer is going to be in square units, because we're really counting all those individual squares. And that wraps up. Wow, that wraps up a quick one. We've been connecting these polyhedra, these solids, with their net and using that net to calculate the surface area. But we're starting to dabble in two things, volume, and we're also starting to dabble with getting the surface area without using the net, by imagining the net to use to calculate that surface area.